Okay, this is on similar triangles. We've done similar polygons. Okay, now let's do similar triangles. Okay, similar triangles. First, the author goes through some postulates and some theorems. Okay, the first thing they go through is postulate 7.1. Okay, and it is called the angle similarity. Remember, we did some of these with congruence. Okay, and now we'll do some with similarity. So, and they will abbreviate this in the book. Just angle. Okay. Okay, and it says if the two angles of one triangle, and you can just use the symbol for triangle. And if you think about it, okay, if you have two angles that are congruent, what's that make the third angle? Third one has to be, right? So, if all the angles are congruent, okay, so on this one, if the two angles of one triangle are, and use the symbol for congruence, okay, to two angles of another triangle, then the triangles, just use the symbol for triangles, then the triangles, that's like my apostrophe S, then the triangles are, and remember the new symbol for similar is just a little curve. Okay, if two angles of one triangle are congruent, okay, that means they're the same size to two angles of another triangle, then the triangles are similar. Okay, so draw a picture. Okay, don't skip this in the notes. Okay, I can do better. Okay, draw one triangle. This is the advantage of the computer. As long as you draw it from the, expand it from the corner, you're okay. Okay. So on this one, I'm going to label this P, Q, R. Okay. And I'm going to label this one T, S, U. And label the angles. If angle P is congruent to angle T, and angle Q is congruent to angle S, well, if those two are congruent, it forces the other one congruent. So, and they are triangles, so then they are similar. Okay, so that is called angle. Okay. Okay. The next one the author goes through is theorem 7.2. This one is a theorem. Theorem 7.2 is side similarity. Side similarity. Okay. Side, just SSS. SSS, yep. Okay. And if the lengths of the corresponding sides, if the lengths of the corresponding sides of two triangles that's my apostrophe S, of two triangles are proportional, so they have to be in the same ratio, so they are proportional, then the triangles are similar. Okay? Okay, and that's so far if we have two triangles, if we have two angles congruent or all the sides proportional, then they are similar. Okay? Picture, draw a picture. Try to make them look alike, except one a little bit larger than the other one. Okay? Okay, and I'm going to label this one P, Q, R, and this one T, S, U. Okay? Now, don't mark any angles. The sides have to be in proportion, so I'm going to go P, Q, has to be in proportion to S, T. Q, R, has to be in the same proportion to S, U. And RP has to be proportional to UT. Okay? And then, if that's true, then triangle. Now, the way that you write it, the order that you write the similarity statement is like P is to T. So it would be P, Q, R. That triangle is similar to T, S, U. Now, I can cycle through those. Like I could go triangle QRP is similar to triangle SUT. Okay? It cycles through on both sides. Okay? Okay, so we've got angle, angle, and we've got side, side, side. Okay? The next one's theorem 7.3. Okay? And this one is side, angle, side, side, angle, side. Okay, and it's similarity, side, angle, side, similarity. I know we did these with congruence. These are similarity statements. Okay. Okay. If the lengths of two sides of a triangle, okay, are proportional to the lengths of two corresponding sides of another triangle. Okay, if the lengths of two sides of a triangle are proportional to the lengths of two corresponding sides of another triangle, and now I would double underline that, highlight that. Remember an and statement? For this to be true, both parts have to be true. Okay, and the included angle, because it's side, angle, side, and the included angles are congruent, so the included angles have to be the same. So if you're looking at the triangles, that's the first thing I would check. If that's not true, don't worry about the proportions. Okay? Then the triangles are similar. Okay? Okay. Okay, so label them. I'm using the same labels: P, Q, and R, and T, S, and U. Okay, and I'm going to say this angle is congruent to this angle. Now, it has to be the sides it has to be the PQ and this one, and then it has to be those, because it has to be an included angle. Okay, so if you have PQ to ST and QR to SU, if those are proportional and angle Q is congruent to angle S, okay, then you've got triangle PQR is similar, triangle PQR is similar to triangle TSU. Okay, so the angles have to be congruent, and then the sides have to be in the same ratio proportional. Okay. Okay, then the last thing the author goes through is theorem 7.4, and these you should recognize. These are called properties of similarity. We've done them in real numbers, we've done them in congruence, and now we're doing it in similarity. Properties of similarity. First one is reflexive. And that just says any triangle is similar to itself. Triangle ABC is similar to triangle ABC. You might. Are you hoping those are over? Oh, those make you think. They're good for you. They're really good for anybody in here interested in the law. Yeah. Two-column proofs are excellent for anybody that's into debate. I wish we had a debate team here. When I was in high school, we had debate. But law, that's really good for if you're thinking about law, or even, if you're going to go into a job where you've got to back it up. Okay? If you say this is true, okay, prove it. Okay, so you got to justify it. Okay. Okay, symmetric property. Remember in real numbers, symmetric property said if A equals B, then B equals A. Okay, symmetric property. Well, hang on. Symmetric property says if triangle ABC is similar to triangle, and I'm going to use DEF, then triangle DEF is similar to triangle ABC. Now, did I turn the letters ABC around? No. Okay. This would be like if A is similar to B, then B is similar to A. Okay. Okay, and the last one is transitive. Transitive property for similarity says if triangle ABC is similar to triangle DEF and triangle DEF is similar to, and I'm going to use triangle XYZ, then triangle ABC is similar to what? Yep, triangle XYZ. Okay, transitive property in real numbers said if A equals B and B equals C, then A equals C. Okay, and those, the reason we go through those are some that you will be tested on. Okay, on the Kansas Math Assessment Test.